was about WebTorrent. Thank you.
Thank you. So hi, everyone. I'm going to talk to you about bringing BitTorrent to the web. So I have this project called WebTorrent that I've been working on for the last 4 months. And the idea is to build a BitTorrent client that works in the browser. So a BitTorrent client that requires no installation, no browser plugin or extension, and interoperates with the regular BitTorrent network. So I'm going to talk a little bit about how that actually works. And also, since we're at CraftConf, how to craft awesome software using NPM, Browserify, and WebRTC. So I learned a lot while building this project, and I think there's some interesting lessons, and I want to share that with you today. And it turns out all three of these tools, NPM, Browserify, and WebRTC, are essential to building WebTorrent. So one of the things that makes YouTube so great is that it's dead simple. I mean, to get started watching a video, user just clicks a YouTube link and the video starts to play. It's basically zero effort and completely frictionless to use. And this, unfortunately, is the state of the art of BitTorrent. So you have a complicated UI, lots of stats for nerds, like 9 seeds in swarm, share ratio, DHT status, etc. Basically, the target audience is you and me, but not the average user. And I think it's way too complicated. So, let's walk through what it actually takes to download something over BitTorrent. First, you have to get a client. This is Transmission. It's one of the better clients, I think. You have to download the installer. This is a disk image. You have to mount it to figure out how to install it. And then you're finally presented with this blank screen. So now you have to go and find a torrent. So you have to navigate sketchy torrent sites that are riddled with porn ads and pop-ups and a lot of misleading links. This is actually one of the better sites. I could actually show it in the presentation. And once you get to a page with a download link, you have to choose from, well, there's 3 download links. Download torrent, magnet download, and download direct. Let's do download direct. That sounds good, right? Nope. Turns out it was actually a trick. So this is a random executable that it downloaded to my computer. So everyone, on your hands, show me, on your fingers, how many different viruses do you think this file actually had in it? 10, okay. 5, all of them. It turned out it actually just had 3, but it's still a pretty horrible user experience. So let's say you ignore all the ads and the malware downloads. You finally, you ignore all that. You find the real torrent. Now you have to open it up. In this dialog you're presented with, you have to confirm the files you want in the torrent. Where do you want to save it? Give it a group, a priority. Do you actually want to start downloading it right now? I can't believe that's an option. Of course, I just said I wanted to download it, right? And then your movie finally starts to download. And look, we only have to wait 1 day and 10 hours before we can watch our movie. Nice. So even in a really good case, you're still probably waiting about an hour before you can actually watch. So given all these problems, why does anyone actually use BitTorrent? Turns out it has much faster downloads than a central server can provide. And you get really efficient bandwidth utilization. So I have a cool demo here of simulation of a swarm. So here we have 2 seeders and a bunch of peers that don't have any content. I don't know if you can see this here. Let me try inverting it. Yeah, that works way better. Cool. So these two peers have the complete file, and you can see the different pieces in the file are represented by different colors. And eventually, you'll notice really quickly, you have people who don't have very much of the file who are actually helping now to seed and to share bits of the file. So, if you leave this here for a few minutes, pretty soon it looks, everyone's connected to everyone, and you have really, really efficient bandwidth utilization. Yeah, so it looks like something like this after a while. Cool, so the BitTorrent protocol is awesome. We can all agree on that. So how do we begin to approach something like the user experience of YouTube? So we're going to do this a few ways. One is we need streaming video playback. We can't make the user wait an hour before they can start to watch their movie. That's just unacceptable. We also want it to work in the browser, so there's no installation and it's easy to share links with your friends. And we also want to have a more elegant search experience. So first, let's talk about how we're going to do this. So the way BitTorrent works now is you have a BitTorrent client. We're just going to represent a client by an orange rounded square thingy. And we have a bunch of clients. And these can be anything, your uTorrent, your transmission, Azurius, whatever. And they're all going to connect to each other and they're going to share. So these orange links represent the BitTorrent protocol. Now, we want to build a new kind of client. We're going to call it WebTorrent. And it's going to speak the BitTorrent protocol, of course. So it's going to be able to talk to all these existing clients. Now, I'm going to put these additional clients up here, these blue ones. And these are actually clients that are running completely in the browser. These are in browser tabs. This is a script tag that's on people's websites. Now, these, they're going to be able to talk to the middle clients. And the reason why we have to do this is because these blue links are WebRTC connections. So WebRTC is a peer-to-peer communication protocol that works in the browser, and it's the only way to do peer-to-peer in the browser. And so so to be clear, these JavaScript clients can't connect directly to BitTorrent nodes. It's just not possible. So these middle nodes, these hybrid nodes, are very important. And so the plan is basically to make these clients use the hybrid nodes to be able to access all the content on the BitTorrent network. So as these clients download stuff, they seed it, and they're seeding to both networks. And now, these middle clients are actually going to be installable because they need to be able to open up raw TCP and UDP sockets. So they're going to be a native app, Windows, OS X, Linux, or even a Chrome app. That kind of thing. Something with the permission to actually open up arbitrary TCP and UDP connections. So this is V1 of the app. It looks just like transmission. It doesn't have the kind of streaming user experience that we're going for. So V2 is going to look something more like this. But basically the plan is, in 3 steps. We have to have an awesome, number one, we have to have an awesome JavaScript BitTorrent client. So we have to write an entire BitTorrent client in JavaScript, which is in and of itself a kind of crazy undertaking. Next, we have to make that client run in the browser because it's Node.js, so it's not going to run in the browser by default. And then lastly, we need to use WebRTC to actually create the peer-to-peer connections. So we're going to do it in 3 steps. First, we're going to talk about NPM, then we're going to talk about Browserify, and then WebRTC. So first, NPM. So the way we want to build this is we want to ultimately have 3 final targets. So the browser JavaScript, the native app that's running on Windows and OS X and Linux, and then we started with the Chrome app. So the stuff in green has actually been implemented. The stuff in red haven't implemented it yet. So, oops, there we go. So this is the full dependency graph. It's pretty big. This is the way people write node programs, lots of small modules that do one thing well. And so just really quickly try to cover what's going on here. So these smaller modules are all doing very specific things that kind of primitives for a BitTorrent client, common things a BitTorrent client needs to be able to do. So there's parsing torrents, parsing magnet URLs, being able to talk to a BitTorrent tracker to find peers, finding peers through the DHT, which is a really cool way to distribute the tracker so that all the peers themselves are actually tracking each other and you don't need to have a central tracker. And then we have this module BitTorrent protocol, which actually takes care of all the complexity of speaking the wire protocol, which is not, it's not JSON or anything that humans can read. It's this weird thing called Ben coding. And that takes care of all that for us. And so then these get all kind of pulled together into this module called BitTorrent client. And so it's what it sounds like. It's just a BitTorrent client. It's a node module. You require it, and then you ask it to download torrents for you, and it'll handle all the complexities for you. And it can give you a stream of a torrent file before it's been fully completed. So you can say, I want to watch this particular file in the torrent. It gives you a stream, and then you do whatever you want with the data, and you start to get data pretty quickly. And that is used by this higher level module, which is called WebTorrent on NPM, and that's a command line client. And it also includes an HTTP server. So it'll actually launch VLC for you, and then it will point VLC to this HTTP server that's running locally on your machine, and anytime VLC requests a bit of the video via an HTTP range request, it will say, aha, okay, I need to go get that piece of the file, and it'll go and tell the BitTorrent client module to go and fetch that part of the file from the network. And then that module itself is going to be used by the final, GUI app that's going to run on OS X, Windows, and Linux, and also it's used by the Chrome app that exists today. And you notice there's this parallel track on the side here, which is the WebTorrent specific stuff. So these modules are going to speak WebRTC, right? But you see how all the stuff on the bottom is being used by everything above. It's a really good way to design software. It's the Node way. I love this animated GIF. Found it on some random Tumblr. Anyway, so basically the idea behind building software this way is you want to have modules that do one thing well. You want to compose larger units out of smaller independent units of functionality. So Substack has a great quote about this. When applications are done well, they're just the really application-specific, brackish residue that can't be so easily abstracted away. All the nice, reusable components sublimate away onto GitHub and NPM, where everybody can collaborate to advance the commons. So this is coming from a guy with over 350 modules on NPM. It's pretty incredible. So he's taken this philosophy to the extreme. There's some really good stuff here. Also, Dominic Tarr, the guy who spoke just immediately before me, also has about 350 modules on NPM as well. I only have 40, but you'll find that most programmers who are doing Node right will have at least a few published modules. And if you compare that to other programming communities like Java, Ruby, PHP, you'll find that a lot of programmers might go their entire careers without ever writing a single reusable package that their peers can use. And I think that's what makes NPM so awesome and powerful, is that publishing is really easy. The problem of dependency hell has been kind of solved. And so this has led some people to actually call NPM Moduletopia. So there's basically a module for everything. 70,000 modules. And because of this philosophy, NPM has a module for just about anything you might want to do, from 3D graphics to advanced math, to database indexes like geospatial indexing, BitTorrent modules, and even video encoding and decoding in JavaScript, because people are crazy. So takeaway is, small programs that are composable are great. And Node isn't really the first to come up with this idea. These are some Unix commands. So the first one just prints out a file. The second one will minify your JavaScript, and then you have gzip, and the last command actually just tells you the number of bytes in a file. And so, these are all programs that are pretty useful on their own, but we can put them together. And when we do that, we get this. So what does this do? Anyone know? Yeah, it tells you the size of your script after you've minified it and gzipped it. So, this is a use case that maybe the person who, created the cat command didn't think about, but the user can put it together in this interesting, novel way. And so these pipes are where the magic happens. They basically take the output from one program and they pass it as the input to the next program in the sequence. So basically, the NPM way summed up is you have a good module system. You want to pull code out of your main project into modules early and often. And modules should do one thing, and they should do them well. And you want to have modules that are easy to test. So NPM has this command that you can add a command that specifies how to run your tests in your package JSON, and then everybody can just run NPM test without having to understand what testing thing you're using, and it'll output the results of your tests. What's cool about that is, if you're working on someone else's code, and you want to send them a pull request, before you do that, you just run NPM test and make sure that you haven't broken anything. So it's really standard, really uniform. Basically, every NPM package does this. And then you have badges and good documentation. Actually, I think that the best documentation is just to have the name of your module explain what it does, and have it be kind of obvious how to use it by just inspecting it in the REPL. So back to WebTorrent. This is the full dependency graph of WebTorrent today. And there's this really cool visualization tool called Yassiv that, well, actually, you can type in any NPM module, and it'll show you this really cool representation of it. And you can see, OK, let's look at BitTorrent client. That's the thing that kind of pulls together everything. And we can kind of pull it around and see, wow, it's really depending on a lot of other modules. But something like the protocol that's way down here is really, it doesn't require too many other things. You can type in any module and check it out. So you can, let's try a really popular one, Express. This is a web framework. It's pretty cool. And let's try another one. This one requires a lot of sub-dependencies. It's pretty amazing. So yeah, you can play around with this. It's just yassiv.com/npm, and I encourage you to type in your favorite npm modules and take a look at what's actually going on underneath. So back to WebTorrent. So let's talk about one module in particular, BitTorrent protocol, and let's see what it can teach us about modular program design using Node.js streams. So to actually talk to another peer, another BitTorrent peer, once you have a TCP connection to them, you're communicating on this duplex channel, right? You're sending data to them, and they're sending you data. And that data is in the form of this protocol that's not human readable. It's not really binary either. It's just this kind of weird way of encoding data that is actually only used by BitTorrent. And we don't want to actually have to deal with that as people who are writing higher level modules. We just want to have a module that takes care of that for us. So this is what this does. So it's a stream, which means that it's going to take data in, and it's going to output data. What you actually hook those ends up to is completely up to you. So this doesn't mandate that you use TCP or anything. So we have this stream of protocols, gibberish stuff coming in, and it's also sending stuff out. Now, let's say the first thing that we get is a handshake from the remote peer. Let's say this data is a handshake. So the way we know that as users of this module is it's going to emit an event, handshake. And so we can handle that however we want. And it might have been another event like request. This means the user is requesting that we send them a certain piece of the file. Now, we can respond to these events by calling methods on an instance of this object. So you do that by, for example, calling handshake. So if you get a handshake event, you want to call handshake in return to basically return the handshake. Similarly, if we get a request event, we want to reply with a data by calling data, saying here's the data for you. And the module takes care of producing the correct Ben-coded output for you. So now what do you hook this up to? So in Node, lots of things are streams. So a TCP socket is also a stream. It's a duplex stream as well. And so you can do something cool like this. Hook them up. So any data that comes in from the peer gets piped directly to this module, and any data this module outputs gets piped back over the TCP stream. And you can replace this with anything. So you could replace it with some kind of WebRTC stream, or with really anything. And so by using a stream interface, this module can be composed with other modules in ways that I, as the module author, could never have predicted, or really ever hope to support as part of the module's core functionality. So they're just like Unix pipes. So actually, how do you use this module now? So let's go through an example use case with the code. So we require the module. Require is just the way you bring in dependencies in Node. So we're going to require net as well. That's the TCP module that's built into the core of Node. We're going to create a TCP server. So we would actually start the server later on by calling listen on this, but I didn't put that in the slides. So you specify a port that you want to listen on. So anytime someone connects to that port, this function is going to run, and it's going to give you a socket. And in there, we're going to create a new protocol object, and then we're going to take the data that the socket is outputting, and we're going to pipe it into the wire, the wire variable, which is an instance of the BitTorrent protocol module. And then we're going to take its output, and we're going to pipe it back into the socket. So this is what that looks like, because it's a chainable API. And then we're going to listen to the events that we're interested in. So in this case, we're going to listen to the handshake event. And then we can handle it however we want. So probably what we should do is send a handshake back. So we call handshake on the wire. Cool. So yeah, you can build really cool things if you use a streaming interface. You can, like I said, compose things in really interesting ways. So cool. So we have a BitTorrent client in JavaScript now, and we created a Chrome app that you can actually use. But what we're really trying to do is build a client that works in the browser, not in Node, right? So now we need to take all this code we've written, all this nice modular code, and we need to build it in such a way that it will run in a browser. And so there's an excellent tool for this called WebRTC. And basically the idea behind WebRTC is you have all this code that has require statements in it, and you want it to be able to work in a browser. So you run your code through WebRTC, and it produces a bundle for you that you can just include in your page. So let's go through an example and see how that would work. So here's just some normal Node code. This is a module that I'm going to call foo, and I'm just going to export a single function, and it's going to take a number and it's going to add 2 to it. Very simple. And let's also do another one called bar that takes in a number and multiplies the number by 10 and returns that to you. And then in another file, which we're going to call main, we're just going to require the 2 modules, and we're going to log out the result of calling passing 4 into bar and then passing that into foo. So this is going to return 42. Cool. So that we could run that in Node, and it would just work. But we want to run it in a browser. And the require line would just fail, because the browser doesn't have a good module system yet. If you went to Crockford's talk yesterday, we're finally getting that in ES6, but this works today. So you browserify the main file, and then we're using this little greater than operator, which tells Unix to pipe the output from the command into a file called bundle.js. So we have a file called bundle with this code that's been bundled together such that all the modules are inside, and the require statement actually works. And we include that in a page with a simple script tag. But what if you're requiring modules that are specific to Node? So there's a stream module and there's a buffer module, and those don't live on NPM. Those are actually built into the core of Node. So what is WebRTC going to do when it sees those? Turns out it's really smart. It's going to replace them with an implementation that works in the browser. So your code will just work. You'll be able to go to NPM and just install any kind of module that was written for Node, and chances are it's just going to work out of the box in the browser, because even if it's requiring these things that are specific to Node, it's going to sub in an implementation that works in the browser for you automatically. But wait, you say, so what if you require something like net or dgram? This is to do TCP sockets, and dgram lets you do UDP sockets. What's it going to replace that with? Because you can't do that in a browser, right? That's a fair point. So what it actually does by default is it just replaces it with an empty file that does nothing. So if you actually run this, it won't work. But turns out WebRTC has a solution to this. So let's say we're running in an environment like a Chrome app where we actually have permission to open up TCP and UDP sockets, because our Chrome app asks the user for that. So Chrome has an API that you have to use to actually open up these sockets, but it's different than the Node one. So what we want to do is we want to have a shim that looks just like the Node API, but it actually calls the Chrome API underneath. So we can tell WebRTC, anywhere you see the net module being required, please instead require this other module. And so I wrote 2 modules for the net and the dgram APIs that basically, they expose the Node API, but underneath they call the Chrome APIs. And so you add this to your package JSON, and then when you WebRTC your package, it will automatically do a replacement for you. And it will just work. So this is just for Chrome apps, obviously. But you could do the same thing for a Firefox OS app or whatever. But just a reminder, we're still only talking about running in a privileged environment so far. We haven't gotten to running in arbitrary web pages. So to summarize, WebRTC lets you require modules in the browser by bundling up all your dependencies for you. Sweet. So now we have a nice JavaScript BitTorrent client written as a bunch of small NPM modules. and they all do one thing well. And we built it using Browserify so that it runs in the browser, almost. So it can run as a Chrome app, but that's only because they have extra permissions, right? So they can bind to port 6881 or whatever and open up TCP connections. But normal web pages can't do that. So what we really want is we want any website to be able to include a script tag like this. And now they should have a BitTorrent client on their page. And they should be able to use it, let's say like this, for example. They can specify the info hash, which is just the hash that references the file they want. This is referencing a PDF file, and they should say, get me the PDF file, and when you have it, put it into this div on the page. That's one example. Or maybe they should be able to do the same with a movie. So here's the hash of a movie I want. Once you have a stream to it, give it to me, and then I'll set it as the source of a video tag that's on the page. So just to be absolutely clear, we don't want to build something like this. This is using a central server. We want something like this, where the browsers are talking directly to each other. So is peer-to-peer possible in the browser? Let's talk about this. So it sounds crazy, right? What about security? What about the same origin policy? What about asking the user for permission? You're doing this weird thing on their computer, right? You should have to ask for that. Isn't this crazy? No, it's not crazy. It's just WebRTC. So WebRTC is a protocol that's built into, it's part of the web, it's part of the open web platform, and it allows you to establish peer-to-peer connections from one browser to another. It's a web standard, so it's currently in the W3C, and it's also an IETF standard, and it lets you do video and audio chat, very simply, and also supports arbitrary data. The arbitrary data part is really important for us because we want to speak the BitTorrent protocol, so we need to be able to send whatever data we want. And this is huge, right? This fundamentally changes the web, really. It's a huge change because previously data always flowed from the server to the client and from the client to the server, but now it can flow from client to client. And really what WebRTC is trying to do is to bring real-time communication to the open web platform and make the web better and more powerful and more like a full operating system that can just do anything. It's bringing a powerful new primitive to all of us. And so suddenly it's feasible for any one of us to build something like Skype, because server costs are now, they go down close to zero, because all of the content is being sent directly from peer-to-peer, and you don't need a huge server farm to run a video chat service. And so this can be the kind of thing that you integrate easily into your app. So video is now a feature and not a standalone application. And there are really awesome use cases of this already. So this is a site called talkie.io, which you can go to it, and then you say, I want to do a video chat. It gives you a URL. You send it to a friend, and suddenly, the friend visits it, and suddenly you're in a video chat with this person. It's that simple. There's no installation. It works in Chrome, Firefox, and Opera, which is like 60% of all the browsers out there. It works on all kinds of devices, so Chrome and Firefox mobile support this as well. And so all in total, there's about 1 billion WebRTC-enabled devices out there. And here's a video chat happening between Chrome and Firefox. So this stuff is, it's legit. It actually works. You can use it today. This particular video chat was the very first time that Chrome and Firefox were talking to each other, interoperating with each other, using WebRTC. And this is a developer from Chrome and a developer from Firefox having their very first conversation over this. And they recorded it and posted it for everyone because it's kind of a historic moment. Cool. So we're really interested in the data part of WebRTC. So video, it turns out, is really hard, and so they had to do all this extra work to make video work well. They had to figure out all of this stuff with codecs and real-time encoding and decoding of video data, and so it'll be really low latency. They did all this extra work, but fortunately they also said, we're also going to let you send arbitrary data. And you're allowed to send text or binary data, so you can use any of the binary types that JavaScript affords you, and you can do reliable or unreliable transport. So that emulates like TCP, and you also have UDP semantics. And you get encryption out of the box, and you have a really simple WebSocket-like API. So let's see what that would look like. I'm not going to go too much into this, but in short, you basically construct a peer connection, you call a few little methods, and then you get this object called an offer that you need to send to the peer. And how you send that to the peer is up to you, but the peers need to exchange some information so they know about each other before they can actually do a peer-to-peer connection. And so that bit of data that they need to exchange needs to go through a central service at first. But then once that's happened, they can talk to each other. So then we create a data channel. In this case, we're creating a reliable channel, which means that if packets are dropped, it will retry until it arrives at the other end. And you see you can just call send, and you can listen for events by listening to the message event. And if you want to make an unreliable channel, you just say ordered false, which means I don't care the order that the packets arrive in. And you can say max retransmits 0, which means don't even retransmit if the data is dropped. So this is really powerful. You can do lots of stuff with it. Here are some ideas. One really cool use case is first-person shooters. So this is a game that Mozilla released called Banana Bread. It was basically just used the Unreal Engine and made it work in the browser, but they used data channels for the multiplayer. And what's cool about that is because WebRTC supports UDP-style semantics, this is actually very performant. When you're making a first-person shooter, you need to be able to send packets and just blast them as fast as possible and not worry if they don't arrive. So for things like the player's position on the map, that's the kind of thing you just want to blast, and if it doesn't arrive, you don't want to resend, because if you did, it would destroy the performance of the game. So you can start to, you can even imagine making your communication with the server use WebRTC for this reason as well. So you can have the server be a WebRTC node by running, not by running Chrome on your server, but by running a library that implements the WebRTC API. So then your clients can talk to your server, and they'll just think that they're any other peer. But really, you're doing this so that you can send UDP data to the server, which until now has never been possible. And this is useful for other things too, like live video streaming and real-time apps like stock quotes. You know, with a stock quote, you don't want the stock quote from a minute ago. You want the current quote. So if the packet's dropped, just don't resend it. Just send more later, right? So this is oh, and then lastly, you can create your own protocol on top of UDP, which is what we're going to be doing. And this is the module that actually lets you do WebRTC on the server. It's called WRTC if you want to check it out. So I'm running out of time, so I need to speed up here. There are some cool things people have done with WebRTC. This is a way to send files directly to your friends, and no one besides the recipient sees the file because it's peer-to-peer, and it's easier to use than Dropbox. I recommend checking it out. It's called ShareFest. This is a startup that I started a year ago that is a CDN that's completely peer-to-peer. So you add a script to your page, and it does browser cache sharing. What that means is if someone's downloaded some content from your site and it's still in their browser cache, then someone else comes to the site later, they'll ask a central server, hey, does anyone else have this content? And if they do, it will coordinate that so the peers will get connected. And then you know, you'll just, the one peer with the content in their cache will give it to the other, and then it reduces the load on your server. And our startup was actually acquired by Yahoo a few months ago. So, quick tangent, if you were building peer CDN, where would you store all the static content? So you need to be able to put it in the browser cache, right, and get it out, right? So we should be able to, this should work, we should be able to do this, right? Turns out you can't actually programmatically access the browser cache. You have to look into one of these other alternatives, but for various reasons, they're all kind of inadequate for our purposes. The first one's Chrome only, and a lot of them require prompts. But I was looking into the local storage spec, and I noticed it says, has this interesting thing about limiting the total amount of space that each site can get, and guarding against storing data under other affiliated sites, which means subdomains. Basically saying, don't let a site with lots of subdomains get more space than it should. So I tested this, and it turns out Chrome, IE, and Safari completely ignore that recommendation. So every subdomain gets its own 5 to 10 megabyte quota, and since subdomains are free, we have unlimited disk space with no prompt. What can we do with this? I wonder if we can do anything useful. Turns out we can do something like this. Now, what's nice about this is we're getting around 40 megabytes per second of write speed to my disk since I have an SSD. So, don't use this for evil, please. I think it's cool, but I appreciate a good troll as much as the next guy, but I reported this as a bug in Chromium, and it's been a year, and it's still not fixed. So back to WebRTC. I am way behind on time, so I'm going to really quickly run through how peers find out about each other. So peers want to talk to each other. You call this constructor. Like I said, there's a bit of data that you need to send from one peer to another. So both sides want to communicate with each other. They need to agree on a shared secret to encrypt the data channel, and they need to send that to the other side. So similarly, the other peer needs to send a bit of data back. That all goes through the central server. There's a bit of a complication, though, because we have NATs. So I'm skipping some of this. Sorry about that. But basically, we need to find out what our IP address is. So we have to use this service called stun, which will tell us what our router's public IP is. So we send a packet to that. It replies. Now we know our own IP. Similarly, the peer does the same. And so we have this thing called an ICE candidate, which is basically just a little JSON representation of what your IP address is. And then we again have to forward that through the central server. And at this point, we can establish a peer-to-peer connection. So you have to do a little bit of mumbo-jumbo to get going, just so for security reasons, to ensure both sides want to communicate so that the peers can be introduced to each other and so that we can work around NATs. So there's a bit more of, I wish I had time to explain about how to actually make WebRTC suit our purposes for WebTorrent, because we really don't want to go through a central server every time we want to find out about new peers. But to summarize it shortly, basically the idea is when we want to talk to a new peer, we can use an existing peer as that central server. So basically, when I want to talk to peer A, and I'm already connected to peer B, I can say, hey, B, can you please introduce me to A? And that little mumbo-jumbo you just saw will actually go through the peer B. And then I'll be able to establish new connections that way. OK, so wrapping up, we have a nice JavaScript BitTorrent client written as a bunch of small NPM modules. They all do one thing well. Each module is independently useful, and others can and will use them. And it runs in Node, and so that means it works on OS X, Windows, and Linux. And we built it using Browserify so that it runs in the browser, almost. And then we need to sub out a little bit of functionality and use WebRTC instead, because web pages don't have permission to open up arbitrary connections. And so, yeah, I encourage you to check out NPM, Browserify, and WebRTC and use them in your projects. They're really cool, and I think you can build awesome things with these three technologies. If you're looking to get started with WebRTC in particular, I encourage you to check out Simple WebRTC and Peer.js. So Simple WebRTC is literally one line of code. You can do a video chat in your browser. It's really simple. It's like jQuery for WebRTC. And Peer.js is the same thing, but for data, for arbitrary data. So they'll get you up and running in no time. And please check out WebTorrent. The address is webtorrent.io, and give it a shot, and please share your feedback. So happy hacking. Thanks.
Thank you. We're kind of out of time, so I'm just going to squeeze in one